What's up, ladies and gentlemen, welcome back, and today I'm going to show you how to make the only dome generator you will ever need. Let's get started. Okay, so let's start off with setting a point in Rhino. Now in Grasshopper, let's set in point and assign it to our component. Let's add in a polygon, which now you can move freely, like that. For the radius, I'm going to place in a number slider of around 10. I'm going to bring this down to about 8. Copy and paste this, bring it into the segments. I'm going to bring it to a value of about 5, and I will reduce this number slider's minimum value to 3. Okay. Let's make this into a group. I'm going to call this one base geometry. And now I'm going to get myself a move here. And I'm going to place this point into the geometry. And I'm going to give it a z vector for our motion. And a value of around 10 as well. You can change these values later if you want to. Another group. I'm gonna name this one top point. And now down here, I'm gonna get myself an explode curve. Bring in the polygon, and I'm gonna get myself a cull index. I wanna bring in the vertices, because if we only have 5 segments, we won't be needing 6 vertices, but just 5. Then add in a panel with a 0 in it, place it in the indexes, and that should bring us down to 5 points. Good. Let's group this. I'm gonna name this one here breakdown. Now let's first off hide all of these elements like that. I'm gonna place in a curve middle. I'm gonna bring in all my segments into here. Also get a move, place it into the geometry, get in a z value into the motion, and I'm gonna get a number slider with a value of around 10, place it into there and bring it down to about 6. Next up, I'm gonna add in a scale, and in this case, let's bring our segments into here once again. Let's also bring in the midpoint into the center, and add in a 1.0 for our number slider to serve as our factor. I'm gonna place this at around 0.9. That looks good. Okay. Now let's get ourselves some endpoints, and we can connect our geometry into there to get the endpoints for our arcs. And just to see how this looks, I'm gonna add in a line, bring it there, and you want to bring in your geometry into the start point, and then both the start and end points into the end point of the line. Okay, as you can see, it looks a little bit messed up, but to fix this, we just need to place in a flatten on the start value, and that should fix it up nicely. Gonna group this, gonna name it arc points. You can hide all of these values. Okay. Next up, let's add in a line once again. Placing our geometry on the start point and our list on the end point. We're gonna get ourselves a divide next. Place in our curve, and now get a deconstruct point. Place in our points. Get a construct point, and we will connect our X components and our Y components. Let's stretch this one out a bit far, and now to be able to manipulate these curves, we're going to mess around a bit with our Z coordinate. So let's start off by getting ourselves a remap numbers. Place in the value. Let's copy and paste this one over here. Let's get ourselves some bounds and also get the Z coordinate. And let's place our domain into the source. And of course, get this domain into the target as well. Next up, let's add in a graph mapper, the central tool to our curve manipulation. Let's add in the mapped value and let's place in our graph mapper into the value of the other remapped component. Next, let's add in our mapped input into the Z coordinate, and let's change this graph type to something like maybe a conic. And as we can see here, as we begin to change this, the points start to move, and to see this even better, we can add in a interpolate curve, place it into there. Now we can hide all of this stuff here, and as you can see now, we can easily manipulate our curve. We can also do this by using a Bezier curve to make all kinds of different shapes. I will not recommend changing this point here, since by lifting this line you will not be able to reproduce the proper dome shape or arc. Still, moving these points around, you can get all kinds of interesting results. Okay, now we can group all of these items like that. Select them again, copy and paste. We can get rid of this one here, since we have our value here. Let's add this one into the group. Bring it over here, bring it down here. And I'm gonna name this one Arc Morph. And this one will be named Dome Morph. And as you can see here, all of our curves are now being changed as I make these adjustments on the graph mapping. Beware of certain shapes because they might deform the dome too far. Next up, let's add in a ruled surface up here, and also a shift list. Don't forget to flatten these curves here. Then add your values into here and into the ruled surface, and the shift into the ruled surface as well. Next up, let's join these reps and also cap their holes. Okay, let's add in a scale. Let's place in our geometry into there. For the factor, I'm going to get a number setter of 1.0 and bring it down to about 0.9. I'm going to hide all of these values here. And as for the center, to make sure that the values, also going to unhide this one, to make sure that the value of the scales has a consistent center, let's go all the way back here. Let's set up a new point. Add our previous point into there. Now we can bring this all the way up to the front, like that. And now go Command Shift and bring it into the center, like so. Okay. We can now delete this here. Now let's get ourselves a solid difference, yeah. Let's bring our geometry into the reps B and our capped holes into the reps A. We can now close these, and yeah, that's our base dome. Okay, we can now select all of these elements. We can now group them up. I'm gonna call this one Dome Hollow. And as for down here, we're gonna add in a join curves into there. Let's flatten these down. And now let's get ourselves a construct plane. We can bring our curves into there deconstruct plane into there. Let's also add in a continuity, or in this case, connect curves. Yeah. I usually bring these up because of this specific value here. Let's graph these values, and as for the continuity, we want to change this value to a _0 to keep it nice and straight, like that. Now let's get ourselves an STL line. As for the start, we can use our origin here. For the direction, we can use our z-axis, and for the length, in this case I'm going to give an arbitrary value, so an initializer with a value of around 10. I'm going to bring this to around 7 or 8, which is roughly the radius of our object. I'm going to set up a negative value, bring it into here, and now we can go in 1 and 2. Let's graph these values so that we can have them going both ways. And we can also add in an extrusion. Let's place our new line into the direction and our curve into the base. Okay. Oh. Don't forget to flatten these down, and you should get something like this. Okay, and of course, let's not forget once again to cap our holes. We can now select all of these. Let's bring them into a group. I'm going to call this one arc extrusion. Let's hide these. We can also hide all of these. Okay, so to finish it all off, let's get ourselves a solid difference. Let's bring in all of these elements, like this. We also want to flatten these down. Now we can hide these. And yeah, that's how we make our base dome completely parametric. Let's give ourselves a custom preview here and a swatch. Place in a hue of about 50, accept. Yeah, this is essentially how we set up a graph mapper based dome. Of course, now we can play a little bit around with it. So, for example, here I can modify this value, and of course, always be mindful how you modify it to make sure you can keep the full form. I'm gonna try this out with a Bezier curve once again. So as I pull these down, they will start to deform accordingly. And naturally, the same thing for the arcs. I'm actually going to try out a conic one on this one. Alright, okay. And let's not forget to change the number of sides. So I'm going to try out maybe 7 here. Okay. Alright guys, I hope you've really liked this tutorial on how to make a parametric graph mapper based dome. It was actually suggested by a fellow subscriber, and yeah, I hope you've really liked it. Do not forget to like and subscribe for more videos or to suggest new videos. And yeah, cheers.